Hello everyone, this is Takuta Sakura. Greetings from Tokyo, Japan. It is a hard situation, but I am really happy to have this opportunity to talk about my new product, llmk, which stands for LaTeX Make. So please let me start. First, I would like to give you an interactive demonstration. Suppose we have this tech documents from the author. And can you guess how can you build this tech documents? It is not necessarily obvious because we don't know which is the main text source file, which tech engine to use, PDF tech, ZTech, or LaTeX, or else. And also we don't know what big program to use. Maybe for this really simple example, it is easy to observe files and find out that this meeting.tech is the main source file. But as I said, it is not necessarily obvious. Basically, it is difficult to detect which is the right workflow for processing LaTeX documents. But how about if we were told by the author that we use PDF tech for this document, and the main source is meeting.tech, and the others are input by it. And also we use bibliotech for processing its bibliography. Because you all are experts of tech, now you got that we have to run pdf meeting.tef first, and then run bibliotech for its AUX file. And finally, we again have to run PDF LaTeX maybe for a few times until the all cross references will be solved. Okay, now we got that these a few short sentences are enough to tell the right workflow for human, but how about for systems? Let's tell the exactly same thing to LMK. First, we open a file named llmk.toml and then tell that we use PDF LaTeX for LaTeX command and also use bibtech command for bibliography, and also the meeting.tef is the main source file. Then we save this file and execute the llmk command. The arguments here looks complex, but this is just to grab its output. So basically you don't have to give any arguments here. So now you can see that LMK execute PDF LaTeX first and execute bibtef, and finally it execute PDF LaTeX again. Now we get the final result in PDF format, just like this. So this is what LMK can do and how it works. Now, since Tech, LaTeX, and their friends have long history and got numerous users, so we have a number of related programs. For instance, we have several tech engines, including PDF Tech, ZTech, LaTeX, and also PTech for Japanese documents. And we also have a few options for processing bibliography. We have a few indexing programs, and also we have several debugware. It is really nice to have such a large number of options, but on the other hand, it is sometimes the workflow to process LaTeX documents can be complex, and also it might be sometimes difficult to detect what is the right workflow for processing LaTeX documents. Something we have to concern is that there is no ultimate best workflow which can be used for any purpose every time, but the best workflow is differ from one project to another. For instance, as far as I know, PDF using PDF tab plus bibtech plus make index is one of the most popular workflow, but sometimes it is reasonable to use GTEC and LaTeX instead of PDF tech, especially if you want to use your system font. And also for Japanese documents, it is difficult to process Japanese documents with PDF tech. So PTEC plus DYPDFMX workflow is still the de facto standard for Japanese documents. It is even true for a single user. A person may use different tools depending on the purpose. For example, in my case, I use PDF LaTeX for English documents as the first choice, and GTEF if I want to use system fonts. And for Japanese documents, I use UPTEC and DYPDMX. And also I use LuaTeX when I want to use its Lua features. So we have to tell which workflow to use in a project to human, such as co-authors, editors, and so on, and also to systems like editors, text editors, IDEs, build tools, even in cloud services or in servers. So I thought it would be ideal if we can do this at the same time in an easy and uniform way for both human and systems. Thinking about tailoring the workforce, as a matter of fact, there are numerous existing tools such as GNU Make. I know they are really useful. They can handle any complex workflow if you write correctly. But think about the very simple cases, like just telling we are using PDF LaTeX for this document is enough. Really simple case. Do we always provide make file for all documents, including such a simple cases? And uh, I suppose that workflows for typical small documents are not that much complex, so using such a generic build tool is sort of overkilling. So my hypothesis is that in many cases, just writing we use PDF LaTeX on top of the text file or similar would be just fine. And I'd like to provide an interpreter which can be used anywhere for it, for this purpose. And that is why I begin a new project, llmk, the right LaTeX make. Its mission is to encourage people to always explicitly show the workflow for each document by providing a convenient way to do it. So to complete this mission, its design concept has three important things. That is, it should provide easy ways to specify the workflows. It should work in various environments. And finally, it should behave exactly the same in any environment. Now, I would like to briefly overview the design concept of LMK. So the first perspective of the design concept is convenience. That is, that makes the LMK simple and easy to use. So it supports independent configuration file named LMK. This name is fixed. And also at the same time, it supports magic comments in tag file. That includes TOML fields, which is the original format for LMK, and shebang-like magic comments, and so on. I will describe in detail about these later. And a default configuration of the LMK is do our best style, which should work fine in typical and simple LaTeX documents. So the LaTeX documents, which is typical and simple enough, you don't have to write any configuration at all. And the second perspective is portability. Since LMK is designed to be a method of telling workflow to one another, so it should basically have to work nearly everywhere. So it is designed to be cross-platform. It works solely with stack Lua. It only requires Lua def to work, so I think this can be used almost anywhere if you have tech environment. And something notable is LMK has no user configuration, such as .lmkrc file under home directory. Because LMK configuration is a means of communicating workflows, so a LaTeX documents which have the same LMK configuration should be treated as exactly in the same way in any environment. User configuration is useful, I know that, but will destroy such a portability in this sense. And I would also like to note or insist this that LMK is not trying to replace existing tools like GNU Make, LaTeX MK, Alala, and so on. If a document have makefile, that means they already clearly, explicitly describing its workflow. So I'm focusing more on simple cases that people neglect using them, which don't have makefile or similar. From now on, let me explain briefly about the basic usage of LMK. First, where to write its configuration. When LMK is executed without any arguments on command line, llmk.toml is loaded automatically. Another option is to use TOML field in tag files. TOML fields is, as shown in this example, a special command in tag file. The place which sandwiched by the command line, which includes more than 3 plus marks, TOML field, and you can write the configuration of LMK in the TOML format. As I shown, we use TOML as a format of writing configuration for LMK. This is a small language designed for configuration file. So it is similar to INI formats, JSON, YAML, and so on. It is actually already used by several projects, like Static Site Generator Hugo and Cargo, which is a build system for a programming language Rust. So it is already used for a while. You can find the full spec of the language at https://toml.io. The characteristics of this language is it is designed to be both human and machine friendly. Of course, whether or not a language is human friendly or not is more or less opinion based, but I can say that it is relatively easy to write the person for TOML, because actually I could write the TOML person in a day in pure tech Lua. I will explain about the basics of TOML anyway for your reference. It is basically a line-oriented keyboard list, so that is not so complex. And it is actually a kind of INI extension. So it's have commands that begin with a sharp mark, and it continues to the end of line. The indentation is allowed, but not required, and defining a key multiple times is invalid. It have several basic data types, like strings, which have basic and literal one. So in the double quotation, you can use escape sequences, but in the single quotation literal string, you can it is like the verb command of LaTeX, as you may know. There is also integer, floats, and notably it has date time specific types. And there's also, of course, Boolean. It also has several more basic data types. And here, the types written in letters are not supported yet by llmk because we don't have keys to use those data types. There is, of course, data structures in TOML. One simple data structure is an array, which is the values of the same data type separated by commas. Note that values of the other data type cannot include in an array. The example is shown in the second line of the example TOML. It showed the places which held the tag conference from 2017, Bacotech, Rio, Palo Alto, and this time online. That is an example. And it also have table, which is also known as hash table or dictionary. And for this data structure, no guarantee for the order. An example is shown from the line 4 in the example. The bracket represents for table name, and the table continues to the next table or the end of file. So in this case, the keys hard and snow, which is in line 6 and 7, belongs to the table snowman. And a bit more complicated, tricky case is nested table, which is shown from line 10 in this case. So the key value color equal pink is in the queen table in their table deck. There are also inline tables and array of tables are available in TOML specification, but they are also not yet supported by llmk. But because at this moment we don't have any key to use their features. Let's back to the basic usage of llmk. There is a few important keys in llmk. The first one is the key LaTeX, which is the value of string. It specifies the LaTeX command to use, and the default is the Lua LaTeX. This is because llmk works with stack Lua, so I can 100% guarantee if llmk works, we have LuaTeX in this environment. We also have key dvpdf, bibtef, and so on. And there's also another key, max repeat, which is values of type integer. That is the maximum repeat times of solving cross references, and the default value is 5. As I shown in the first example demonstration in this talk, there's a source key which specifies the source stack files. And this is only valid and required in llmk TOML. So you don't need this key for the TOML field. Thinking about more complex cases, in theory, it is llmk can also do the flexible control for such cases, though this feature is more or less primitive compared to other sophisticated build tools. There are two important data structures for this. One is the sequence array. It is a string array, which consists of the program names in order of the execution. And second one is the programs table, that is nested table that give the detailed configuration for each program in the sequence array. In the example in the below, the sequence includes the LaTeX and bibtef, so this is a very simple case. The detailed configuration for LaTeX says that we use GLaTeX for LaTeX command and use the option recorder. And also for bibtef, we use command bibtef And notably, in this case, we specify LaTeX program as post process so that this GRatex command will be executed after pivtech again. There are many available keys in program tables to do for the details configuration for each program, but I skip the details here because it is boring for you to hear. But anyway, we have these sort of keys available. And also we have special specifiers which can be used for the values for some keys here, just like shown here. These are similar to the specifiers which is available in LaTeX llmk. Now let's talk about the default configuration of llmk. First, what is the default configuration for? It is obvious that writing all configuration from scratch every time is meaningless. Providing do our best style default configuration, which should work for typical simple LaTeX documents, is useful. Doing such, users don't have to write so much for each document, but they only need to write the difference from the default configuration. And notably for llmk, no user configuration is available. This is because with llmk, a text file should be processed exactly as the same way anywhere. Here is the default sequence of llmk. By default, llmk runs LaTeX command first, then run buildtex, make index if the files bib and ind exist. And for the modern tech engines which directly produce PDF, this is all. But if the DBI file is generated, the DBI PDF is executed finally to produce the final result in PDF format. And this is the default programs table in summary. As I said, Lua LaTeX command is used for LaTeX program as default. And we use dbypdfmx for dbi, bibtef for bibtef, and make index for make index. And also, the LaTeX program is set as hook of the post process for bibtef and make index, so that to make sure to rerun the LaTeX program after this program executed. There are also default configuration for dbi PS, PS to PDF, and so on, so please refer to our documentation. This default programs table will be extended on demand in the future, so if you have any request, please let me know. Now I want to share some simple use cases. Case 1. I want to use dbyps instead of dbypdfmx. Actually, there is already configuration for dbyps and PS2PDF in default programs, so modifying sequence is just enough, like shown in the line 5 of this example. Case 2. I want to use my own awesome program. Sure, of course you can use arbitrary command with llmk. Just clear your program in your sequence and then give the detailed configuration in the programs table. Another feature of llmk is cleaning actions. Cleaning actions are available in llmk. But actually, this feature is not implemented by myself, but by a collaborator, so thanks to him. Anyway, we have two types of cleaning action. First one is clean action, which removes temporary files such as AUX, log, and talk files. The second one is Clover, which removes all generated files, including PDF and sync.txt file, in addition to the files deleted by the cleaning actions. Usually, the default configuration should work fine, but of course you can customize it in the TOML field. This feature is really simple, so you can just specify the options to execute these actions. There are a few existing formats that allow us to describe the workflow of the text documents in text file, and which I want to support them as well in llmk. The first one is shebang-like format, which is used by Emacs LaTeX. It looks really like shebang, and using this is just equivalent to write the LaTeX key in the TOML field. Another one is the magic comment used by TechShop, TechWorks, and TechStudio, but this feature has not yet been implemented in llmk, so I would love to observe more about these in the future. By the way, why you want to write configuration and text files from the first place? That is simply because sometimes it is annoying to open another file from text file, especially for small and casual use cases. And in my opinion, it would be compatible with text-specific IDEs and web-based editors. You know that we have this type of toggle menu on TechShop and also similar on Overleaf. I wanted such an easy and handy options not only for specific IDEs, not only for specific cloud services, but available for any tech environments in uniform way. That is almost all about today's talk, but before the actual Q&A session, I would love to answer a few frequent questions. First one is, how does llmk differ from LaTeX? Well, our goals are similar, but not exactly the same. As I mentioned, the mission for llmk is to encourage people to always explicitly show the workflow for each document by providing convenient ways to do it. Thus, there are some differences between LaTeX MK and llmk. But please carefully note that I am not saying that these are the advantages of llmk. These differences are not about advantages or disadvantages, but just about the differences of our design concept in my point of view. First, llmk allows users to write configuration in text files, as I said. And second, there is no user configuration in llmk because llmk is intended to provide a means of telling the workflows to process LaTeX documents to one another. And finally, I would say that llmk makes less implicit decisions for the workflows. That is because llmk always require users to be explicit. The second question, does it give clear error messages? Well, I think there is no perfect for this, but I try my best to make the error message from llmk meaningful. For this purpose, llmk has type checker and its own built-in TOML parser. I know that all of you are already get tired by mysterious error messages produced by tech, most notably missing number treated as 0. Not to add further mysteries in addition to those from tech, llmk has type checker and produce type errors if unsuitable values are given. And I also try to show clear messages for syntax errors as well, with the exact right number that the syntax error happens. Next, what makes llmk LaTeX specific? Well, using it for general purpose is possible in theory, but meaningless because of its LaTeX-oriented feature. These are trivial, but as a matter of fact, magic comment features are text specific because the comment letter percentage is fixed, and also the default configuration is set up for typical LaTeX documents. Finally, the rerun feature that runs until all cross-references are solved is also LaTeX oriented. Finally, what about security concerns? Well, the circumstance is same as the other build tools. However, since llmk always requires explicit configuration, all you need is check to the TOML field or llmk.toml before executing it. Anyway, I should warn this. Do not process unreliable text documents with llmk, especially those you get from internet, without checking their contents. Running llmk is just like running LaTeX with no restricted shared escapes. Lastly, I'm going to talk about the current status and future plan of llmk. The current version of llmk is before version 0.1. Unfortunately, no public release has been made. Similarly, you have to install it manually. But don't worry, it's a single file, so it should be really easy to install it. Please visit our repository on GitHub. And the consideration of backward compatibility, we provide the key named llmk version. You can give the version string to this key. If the compatibility is broken in the future, I'm also not sure what will happen, but at least you will get warning. For the future plan, the most important thing which I have to do is to prepare reference manual. At this moment, we have only short README. Though I believe the README works just fine for normal users, anyway, I agree that reference manual is desired. I will make it as soon as possible and hopefully upload llmk to Citon. And also, supporting other magic command formats is in my plan. Other from that, I haven't decided anything yet. Conclusion. Again, the mission for llmk is to encourage people to always explicitly show the workflow for each document by providing convenient ways to do it. For the above mission, llmk is designed to provide several easy ways to describe the workflows and to work in various environments, and it actually only requires LaTeX in principle. And also to behave exactly the same in any environment. Well done LaTeX projects that already have Makefile or else that explicitly show the workflow is just fine. My purpose with llmk is to fill the gap between manual execution of the tech-related commands and those existing build tools. My desire here is that no more documents that no one but authors knows how to process. So please visit our GitHub repository of llmk. Thank you for your time, and I'm happy to answer your questions and comments. Thank you.